Session 13, Network Operating Systems and Security. Agenda of the session is Introduction to various operating systems which are networking in nature, that is network operating system. So Microsoft operating system, Unix and Linux operating system, troubleshooting modes, TCP/IP troubleshooting utilities, hardware troubleshooting tools, system monitoring tools, and networking baselining. That's the agenda. Microsoft operating system. Need no introduction. I'm sure everybody have used it. Microsoft operating system have networking capabilities built in. Early PC operating systems such as DOS did not. When I started working way back in 1986, we used to have PC DOS. Then Microsoft introduced Microsoft Disk Operating System MS-DOS. So the DOS did not have this networking capability. It was not until version 3.1 with Windows for Workgroups. This Windows for Workgroups was actually the outcome of an agreement wherein Novell NetWare tied up with Windows to provide networking capabilities, and Microsoft used the same technology to include that in version 3.1. Before 3.11, they were using NetWare's LAN, that is the Novell NetWare Local Area Network. That Microsoft included networking components that happened in version 3.11. Windows NT added authentication server functionality, that is a domain controller, but with early version of NT, the focus was still on the LAN, not the WAN. At that time, Microsoft operating systems were not considered scalable enough for enterprise networking, and most web servers on the internet were Linux machines. Windows 2000 built more heavily on internet connectivity and added features to the server products that made it more suitable for enterprise-level computing, including robust directory service, that is Active Directory, industry standard security protocols such as Kerberos and IPsecure, and load balancing and cluster support. The next generation of Windows Server 2008 and 2012 continued this trend and embraced the idea that network is the computer to a larger context than ever. Unix and Linux operating systems. Unix existed for over 50 years. In fact, first time it was introduced in 1969. Unix is one of the most flexible and powerful operating system. The goal of Unix was to provide a multitasking and multi-user operating system that supported application portability. This tradition has continued in all Unix variants. Given the new perspective of operating system portability, Unix continues to evolve and grow. Timeline for Unix and Linux and GNU. It started in 1969. Ritchie and Thompson create AT&T Unix. In 1971, Unix version 1 came that was rewritten in B language. Unix version 2 came that was written in C language. That happened in 1972. In 1976, BSD released Berkeley software distribution. In 78, Unix time sharing system 5 was introduced. In 1982, AT&T's first commercial Unix system was launched. In 1983, Richard Stallman launches GNU. GNU is not Unix. In 1985, Richard Stallman creates the Free Software Foundation FSF. 1987, Andy Tenenbaum creates Mini. 1988, Richard Stallman creates the GPL, General Public License. 1991, Linus Benedict Torvalds creates i386 Linux. and 1992 Linux licensed under GPL. That was the major development till 1992, and the rest is history. AT&T Unix. Unix began as a small research project at AT&T Bell Labs in 1966 and 1969 for the DEC PDP-7 computer. Dennis Ritchie and Ken Thompson designed and built Unix as a way to replace the Multics operating system already in use at that time. Once Multics was withdrawn at AT&T, Thompson and Ritchie developed Unix on PDP-7 in order to play a game. That game name was Space Travel. The first useful version of Unix, that is version 1, was introduced in late 1971. It was written in a B language, which is a precursor of the C language. It hosted a small number of commands, many of which are still available in C language, that is cat, cp, ls, who, etc. GNU Linux. Richard Stallman created an organization to build Unix-like operating system. He had tools, a compiler, and a variety of applications, but he lacked a kernel. Linus Torvald had a kernel, but no tools or applications for which to make it useful. So that is the reason we started using the term GNU Linux. Linux referred to kernel developed by Linus Torvald at age of 21, and the remaining software, that is shell, compiler, toolchain, utilities and tools, and plethora of applications operate above the kernel. Much of this software is GNU software. That is the reason we use GNU Linux. In fact, the source code that makes GNU Linux operating system dwarfs that of the kernel. Therefore, we call the entire operating system Linux as misnomer, to say the least. Troubleshooting. General approaches to troubleshooting. Efficient technique shorten the overall troubleshooting time. General approach to troubleshooting is first look for symptoms. Two extreme approaches to troubleshooting almost always result in disappointment, delay, or failure. At one extreme is the theorist or the rocket scientist approach. This rocket scientist approach, the rocket scientist analyze and reanalyze the situation until the exact cause of the root of the problem has been identified. Few companies can afford to have their network down for hours of days. At the other extreme is the impractical or caveman approach. The caveman first instinct is that start swapping cards, cables, and software until miraculously the network begin operating again. This approach may achieve a change in symptoms faster, but it is not reliable. So first is extreme theorist, that is rocket scientist approach, and second is we can't afford that first approach also, and second is caveman approach. Better approach is somewhere in the middle. It is important to analyze the network as a whole rather than one extreme approach. A systematic approach minimizes confusion and cuts down on time. So what we do is we follow layered model for troubleshooting as well. OSI reference model, upper layer 5 to 7 deals with application issues and are implemented only in software. The lower layers 1 to 4 handle data transport issues. Layer 3 and 4 are generally implemented only in software. The physical layer, that is layer 1, and the data link layer, that is layer 2, are implemented in hardware and software. So the TCP/IP model, the application layer in TCP/IP suites actually combine the functions of three OSI model layers: session layer, presentation layer, and application layer. The transport layer of TCP/IP is responsible for exchanging segments between devices. The Internet layer is responsible for placing messages in a fixed format that allows devices to handle them. The network access layer communicates directly with the network media. There are three main methods of troubleshooting: bottom-up troubleshooting method, top-down troubleshooting method, and divide and conquer troubleshooting method. The bottom-up troubleshooting method starts with the physical component and move up through the layers. Good approach to use when problem is suspected to be a physical one. Then top-down troubleshooting method. Start with the end user application and move down the OSI layers. Used for simpler problems or when you think the problem is with the piece of software. Then we have divide and conquer troubleshooting approach. Start by collecting user experience of the problem, document the symptoms, and then make an informed guess as to which OSI layer to start your investigation. For example, if the user can't access the web server and you can ping the server, then you know that problem is above layer 3 because physical reachability is already there. Guidelines for selecting a troubleshooting method. To quickly resolve network problems, take the time to select the most effective troubleshooting method. For example, two IP routers are not exchanging routing information. The last time this type of problem occurred, it was a protocol issue. So you choose the divide and conquer troubleshooting method here. These are the guidelines. So determine the scope of the problem, limited top-down approach. Analyze the symptoms and then apply previous experience. So if you are using starting from previous experience, that is bottom-up approach. Experience before, if you have already done that, so divide and conquer. Gathering symptoms. Step 1, analyze existing symptoms. Step 2, determine the ownership. Step 3, narrow the scope. Step 4, gather symptoms from suspect devices. And step 5, document the symptoms. Analyze existing approach. Determine the ownership. Is the problem within the autonomous system? If yes, narrow the scope. If no, contact external administrator. These are steps, guidelines. And these are some of the commands: ping command, traceroute command, telnet command, show IP route command. These are all commands which you use for troubleshooting. Documenting your network. To efficiently diagnose and correct network problems, a network engineer needs to know the network baseline. Network documentation includes three components: network configuration table, and system configuration table, and network topology diagram. Network configuration table. It contains up-to-date records of hardware and software. And system configuration table contains baseline record based on the end system device workstations. Network topology diagram is the graphical representation of a network which illustrates how each device in a network is connected and its logical architecture. Routing protocols can also be shown in this. This is example of network topology. Document your network so you can see the routers and the network and how they are connected. Troubleshooting utilities for TCP/IP. Software troubleshooting utilities. NMS tools, network management system tools. These tools include device level monitoring, configuration, and fault management tools. Network monitoring software graphically displays a physical view of network devices. Cisco View, HP OpenView, SolarWinds, and WhatsApp Gold is available for this purpose. Knowledge base, online network device vendor knowledge base also become very indispensable source of information for your troubleshooting. Baseline tools. Baseline tools helps you draw network diagrams, helps you keep network software and hardware documentation up to date, and helps you cost effectively measure baseline network bandwidth use. The figure here shows you a screen chapter of SolarWinds LAN Surveyor and CyberGauge software. This software I'm referring here. Then we have protocol analyzer, Wireshark and other. There are a lot of protocol analyzer tools out there. They decode the various protocol layers in a recorded frame and presents this information in a relatively easy to use format. This figure shows a screen capture of Wireshark protocol analyzer, this one, and we use it for audit purpose and security audit purpose. Hardware troubleshooting tools. Hardware troubleshooting tools, we have network analysis module. Network analysis module name can be installed on Cisco Catalyst 6500 series switches and Cisco 7600 series routers to provide a graphical representation of traffic. Then we have digital multimeters. These are test instruments that are used to directly measure the electrical value of voltage, current, and resistance. These are tools I'm talking about. Digital multimeter. This is DMM. Then we have cable testers also, used to detect broken wires, crossed overwiring, and shorted connections and improperly impaired connections. Then cable analyzer are multifunctional devices that are used to test and certify copper and fiber cables for different services and standards. Protocol network analyzer, portable network analyzer, sorry. The portable device that are used for troubleshooting switched network and VLAN. This is network analyzer. By plugging the network analyzer in anywhere on the network, a network engineer can see the switch port to which the device is connected and the average and peak utilization. This analyzer can also be used to discover VLAN configuration, identify top network takers, analyze network traffic, and view the interface details. Troubleshooting details, tools, research activity. This is for your reference. Network management systems. Refer to this link. Baseline tools, knowledge base, protocol analyzer, hardware tools, then cable testers, cable analyzers, network analyzers. Monitoring and networking baselining. Monitoring network performance data. Sophisticated network management software is often used to baseline large networks. For example, Fluke Network Superagent module enables administrators to automatically create reports using intelligent baseline feature. This baseline detailed report, it will generate these kind of reports. In a simpler network, the baseline task may require a combination of manual data collection and simple network protocol inspectors. Hand collection using show commands on an individual network device is extremely time consuming and should be limited to mission critical network devices. Why is establishing a baseline important? Establishing a baseline network performance baseline requires collecting key performance data from the ports, and devices that are essential to network operation. How does the network perform during a normal or average day? Where are underutilized and overutilized areas? Where are the most error occurring? What threshold should be set for the device that needs to be monitored? And can the network driver deliver the identified policies? These answers of these questions set your baseline. So why is establishing a network baseline important? These are all examples of reasons why should we create that. Steps for establishing a network baseline. 3 steps for planning the first baseline. Step 1. Determine what type of data to collect. When conducting the initial baseline, start by selecting few variables that represent the defined policies. If too many data points are selected, the amount of data can be overwhelming. Step number 2. Identify devices and ports of interest. Devices and ports of interest include network device ports that connect to other network devices, servers, key users, anything else considered critical to operations. By narrowing the port pool, the results are concise and the network management load is minimized. Step number 3. Determine the baseline duration. Should be at least 7 days to capture any trend. A baseline needs to last no more than 6 weeks. Generally, a 2 to 4 week baseline is adequate. The figure here shows examples of several screenshots of CPU utilization trend captured over a daily, weekly, monthly, and yearly period. This is daily graph, this is weekly graph, this is monthly graph, and this yearly graph. You can easily see the trend here. The yearly trend show in the example is too long a duration to provide meaningful baseline performance details. Baseline analysis of networks should be conducted on a regular basis. That's all for this session. Thank you very much.